Good morning. Can you all hear me? Okay. If you can't hear me, just let me know. I'll try to speak louder. Let me first say that it's a great pleasure for me to be here, and thank you all for being here. Feel free to stop me anytime. This is a piece of work we've been doing for the last 2 or 3 years, where we've collected a lot of very large data sets from social media, and this one particularly is on Twitter. I'm going to be talking about how we have leveraged this data set to understand how news articles from different news agencies propagate on social media. And in particular, we use very large-scale networks, and we're trying to build some prediction models to see how far and how fast these articles will propagate, what their lifespan will be, when they will die, and we exploit the network characteristics. So I'm going to be sharing with you some of the visualizations and some of the analysis we've done with this particular data set. So just raise your hand if you have questions and we'll stop. I may not be able to go through everything, but it doesn't really matter because we can have more discussions. So I'm actually a professor of information systems and computer science at the University of Arizona, and I have a research center called Insight, Center for Business Intelligence and Analytics, and this is one of the projects we're working on. We also have other projects on healthcare where we're predicting things like how many people will show up in an emergency room for respiratory-related problems. And Twitter is, of course, one of our big sources of data there. We also use sensors. We also use a lot of large data sets stemming from the Internet of Things, so things like the Fitbit and Nike Fuel, things like that. So we have many different projects going on. So the one that I'm going to be talking about is particularly related to news articles. So we all know social media is very important for news, propagating news articles, different kinds of news, and Twitter in particular has become a huge hub for news. News actually originates, people hear about it on Twitter. These are some numbers. I'm sure these numbers have expanded by now. These were as of, I think, a few months ago. And I know every time I turn around, the numbers on Twitter keep growing exponentially. Of course, credible news appears on social media, especially Twitter, before it appears anywhere else on the web. The earthquake, apparently, that happened in the East Coast a couple of years ago, before the earthquake could reach DC, the Twitter news had reached DC. So if we had some real-time analytics, we could have warned people. And we've seen a lot of things about the election controversy in Iran and the Egyptian revolution and so on. So this particular work is really about news article sharing. It's not about memes in news. It's not about hashtags. It's not about kind of topics in news. It's really about how news articles that originate from different news agencies such as Washington Post, Forbes, New York Times, etc., how they spread, how they propagate, what sort of network structures they form, and what these network structures actually tell us about the lifespan of articles or how they spread, etc. And so the crux of this whole work is really about how do these news agencies, how can they measure themselves? How can they benchmark themselves against their competitors? What sort of strategy should they have in terms of what news articles they should be tweeting about? Who's their audience? And ultimately, to connect it with things like pricing schemes, defining new kinds of business models for using this kind of spread and propagation through social media. So I'm sure everybody in this room uses Twitter, right? Okay, and you probably also read some news through Twitter. So if you look at Twitter, you have the 140 characters, incredibly powerful 140 characters, because embedded in these 140 characters is typically a URL for a news article. But when you actually collect this data through Twitter's APIs, there's a lot more information you can get. You can get user profiles. You can get where they're tweeting from if they chose to share their spatial location. At least you can get their location through their user profile. You can also get hashtags. And then when you go connect to the articles themselves, you can get a lot more information about who the authors of the articles were, what genre it is, when it was tweeted about, when it appeared on the website, lots of things like that. So you can take all of this data, analyze it, and start to add context about the patterns that you see. So our objective here was really to understand and compare the influence of different news agency brands in a microblogging environment. And in particular, we wanted to leverage network analysis because this propagation is really a network that forms. So we wanted to measure news article cascades caused by users' participation on Twitter, and also try and understand the role of followers versus people who don't follow these news agencies. There's a lot of fixation in social media in general in trying to maximize the number of followers. And so it's interesting, it was interesting for us to look at the role that followers play versus non-followers. And I'll tell you a little bit of what we found in that. So we've identified and used new network measures, things that are not standard in the network literature. And it's really leading us towards theory development or a generalized model for online news article propagation. So as I said, my main area of study, I'm really a data scientist. Everything about data, I'm a data nerd. It's really about looking at data and building stories out of data. Sort of like what data journalism is, where you're using data to tell a story. Here we're building all kinds of stories. So interaction networks to me are a wonderful way to extract relationships among pieces of data, link them together, and then use them to add context, the external context like the demographics, etc., to understand what these structures are telling us. So when you look at news articles on Twitter, well, someone tweets, it's either the news agency or a user. And you can construct many different kinds of networks. You can construct user-to-user networks based on who's tweeting, who's retweeting them, replying to them, and you can start to look at cascades of tweets and retweets. You can also build user-to-user interactions because you can look at who tweeted and the user that retweeted them and how many times they retweeted them, etc. And now you start to extract what we call implicit networks and making them explicit. So the explicit networks on Twitter are usually the follower-following networks. The implicit networks are those that are created by people's activity in tweeting and retweeting each other. There are other kinds of implicit networks, like ones based on hashtags, if people happen to use the same hashtags, or if they happen to tweet the same articles, you can connect them together. So there are lots of different kinds of implicit networks. And that's really the more interesting thing for us in our team, is to extract these different kinds of implicit networks and understand them. And look at their patterns and also look at them temporally, because you have timestamps associated with every tweet. And then you can start to explain or understand these patterns and then predict things based on external contextual information like demographics or the news agency that's being tweeted, or the news article types, the genre of the article, the topic of the article. And then it's also interesting to see temporal comparisons. You can do dynamic network analysis, and I'll show you some visualizations as well. So the challenges in extracting these networks, these data sets are very large, hundreds of millions of tweets, several 100,000 users typically, even if you take a snapshot at a time, say a week or a day or even 2 months or whatever. Construction and analysis requires different techniques, scalable techniques. Visualization is very complicated, and then the manipulation of these networks is even more challenging. But if you're able to construct these networks and visualize them, that tells you a story. And then you look at their underlying mathematical structures, then you can build even better stories. So that's what we're trying to do. So, are some of the questions, and I may not be able to cover everything in today's talk, but I'll focus on things you're interested in. How do different news agencies compare in volume and extent of spread? How do articles from different news sources spread and survive, and what's their lifespan? How long do they last? How do rates of spread compare across? So if you're a news agency, do you know how to benchmark yourself? Do you know how well you're doing on Twitter? How does that eventually lead to subscriptions, etc.? Those are all the questions we want to be able to answer eventually. And if there's a difference in the propagation patterns that are caused by followers versus non-followers. So these are just some of our questions. There's more, but I'll try to focus on these. So what we did was, for this particular study, I'm going to report on these 12 news agencies, and you see they span a large spectrum. So they range from general news like BBC, Reuters, etc., to very financial-oriented news agencies like Forbes, Financial Times, Bloomberg, and then, of course, technology like Ars Technica, Mashable, Wired, etc. Of course, some of these, like Ars Technica, now also have all other kinds of articles as well. So we picked 12 agencies that we wanted to look at. Our sample really has much more now. I think we've got about 50 different news agencies now, but here I'm really going to be talking about a comparison of these. What's interesting is, of course, they all have a major Twitter account, and then they have additional Twitter accounts. So we took their main Twitter account. We have a Twitter username, and then we only collected tweets that had embedded in them articles from one of these agencies. So every tweet in our data set, in our clean data set, has any tweet that contains an article from one of these 12 news agencies. Sometimes tweets have multiple articles embedded in them, but for the most part, they have a single article from a single news agency. So that's our data set. This particular study is over a data set collected over a period of 1 year, from November 2012 to 2013. And as I said, containing valid URLs of articles from these news agencies. We excluded, so when we collected it, one of the big challenges with big data when you collect these data sets is the cleaning. Cleaning actually takes up about 80% of the effort. And some of these URLs that were embedded in the tweets either led to nowhere, so they were broken links, or they pointed to the homepage of the news agency, in which case we kind of removed those kinds of tweets. There were also accounts that were simply stopped by Twitter at some point because some of these were bots or some of these are fake accounts, and Twitter from time to time goes in and blocks some of these accounts, so we had to remove those. And so we have several 100 million tweets in our data set, and all of this was collected through the Twitter streaming API. So our first question was, how do different news sources compare in volume and extent of spread? And so we constructed a network. So the network looks like this. We have, let's say a tweet initiates with New York Times, and it's retweeted, so it has an article embedded in it, as you can see here, and it's retweeted by 3 people, or people reply to it. So you can figure that out by parsing through the data. And this is what the network starts to look like. So news agency or someone tweets a news article, it's retweeted by different users, the nodes, and then those might be retweeted further. And so what you start to see is a cascade like this. So we took this and we mathematically represented it using a network. And a network typically consists of nodes and edges. And then you can have weights among the edges. So the nodes here are users. So in our network, we have user to user. So a user who tweets and a user who retweets. So if I am New York Times and I tweet, let's say 100 articles, and you retweet 20 of those, there's a directionality involved, and also there's a weight involved, so it's 20 of those 100. Sometimes I might retweet 5 articles, and you might retweet 3 of those articles. And so you can see this is a weighted directed network, and this is what we call a Twitter activity network, or a TAN. And this reflects user participation in news propagation for the entire time period. So we've taken it for their entire period of time. So this is one of our networks. Well, it looks like a giant hairball that my cat threw up, right? What can you possibly do with something like this? Well, the first time we were able to construct this large network, we had a lot of jubilation in my research lab because it takes a lot of effort. But then we looked at it and we started zooming in on it. So this is 1 week's activity on Twitter for New York Times. In our data set, a clean data set, we had 58,000, almost 59,000 nodes, which is users. And one of these nodes is the New York Times node, the Twitter handle. The rest are all people like you and me, famous journalists, even authors of these articles. And then there are ordinary people like me tweeting these articles. And there were almost 30,000 edges among these people, weighted edges. So this is just 1 week's worth of activity. And you can see that in the periphery, there are lots of nodes. These are individual nodes, people who've tweeted articles. Nobody has retweeted them. But then you can also see these they look like fireworks. And so this is really a heat map of the network. So the orange color shows a high density of tweet, retweet activity, and the whites are kind of lower activity. And then towards the periphery, it's individual people tweeting individual articles. This is what Washington Post looks like. It's for the same week. It's a little bit different kinds of cascades, different number of cascades, and so on. You see there in the left-hand corner, so towards your left side here, you see what you see is a big, fairly dense cascade, and then in the middle you see the WashPo news node, the Twitter handle. And so often cascades are created not just by the news agency, but other people. And these people are what I would call the influential people. And they're not necessarily influential in terms of having a verified Twitter account. It could be anybody who kind of causes this influence to happen and propagate. This is an example of Forbes. Again, a lot of different cascades. For Forbes, what we saw was a lot of individuals cause cascades, and it's not just the Forbes Twitter handle on Twitter that causes these cascades, but a lot more other kinds of people causing them. We've also looked at the day-wise variation, similar structures. This is for New York Times. This is weekdays, Monday through, and then of course one weekend day, Saturday. And pretty much very similar, a little less dense on certain days, fewer tweets on certain days, more on certain other days. Little bit of variation on a day-wise basis. So this is just the visualization that I showed you. And just the visualization, you can zoom in on it. You can look at who's causing ripples, who's causing long cascade chains. But what's very interesting is to kind of go in and analyze the mathematical properties of these networks, because they tell us quite a bit. So here, we've looked at something called propagation depth, which is defined as the number of cascade levels, which in network parlance it's called eccentricity. And so it's derived from the distance in a network. And the maximum eccentricity is called the diameter. So that tells you how long the cascades are, like how many people involved in different chains. And you can look at it from a news agency perspective. You can look at it on a day-by-day basis. So you'll see the days in different colors. You see the diffusion depth or the propagation depth. And you look at news agencies, you can see that BBC on an average has very high propagation depth, and it kind of drops off. Financial Times, fairly low. So BBC, Washington Post, New York Times have on an average some of the highest propagation depth, and more or less the same across the different days of the week. The lowest weekly propagation depths are for Financial Times, Guardian, Ars Technica. So the chains essentially, on an average, are much shorter for these news agencies as opposed to the other three that I just showed you, BBC, New York Times, Washington. So that itself is interesting. But then when you look at some of the metrics, we look at the sizes of these networks, they're very different. So you can see how BBC has about 380,000 nodes in their network, whereas someone like Bloomberg only has 26,000. Ars Technica has 13,000. But then the diameter doesn't always correspond. The maximum doesn't always correspond to the size. So Bloomberg, although it has way fewer nodes and edges, the diameter, rather in terms of the propagation, the maximum propagation depth is 10, which is much higher than some of these others. Question? So actually, we picked the Guardian handle that had the maximum propagation. It had the maximum influence. This is the one. And yes, in terms of the maximum number of tweets and retweets produced. So that's why we picked like the one handle for each news agency. Now, you actually pointed out something very interesting about BBC. For BBC, actually, the three different news handles, they tend to reinforce each other very well. Whereas New York Times has multiple news handles, and they don't tend to reinforce each other like BBC does. So what BBC does is one of them tweets, one of the handles tweets, and the others retweet, and they actually almost equally kind of spread out. Whereas for all the others, the secondary handles don't really act as very good propagators. So that's very interesting when you look at the networks. So you've actually noticed something interesting. And then for the other, like New York Times has 7 or 8 different handles, which are fairly influential, but none like the BBC, just the 3 handles. And that you see only when you kind of look at the aggregation of the propagation patterns. If you just look at number of tweets, so these are not just people retweeting those handles, but in general, retweeting others as well. So the other interesting thing is, if you look at Guardian, for example, the diameter is 14. They have about 155,000 people in their network. WashPo has about 100,000 people. A maximum diameter, the maximum propagation depth is about 15. And what's interesting is that the edge-to-node ratios are they kind of vary, and it doesn't really matter how many nodes there are or how many followers there are. Look at the edge-to-node ratio. It kind of ranges from about 0.2, almost 0.3 to about a little bit more than 0.4. So that's quite interesting. So the interesting thing about BBC, as you pointed out, is there are 3 major seeding nodes that act as seeders: BBC World, Breaking, and News. The lowest diameter is for Guardian, but it also has the highest edge-to-node ratio. That means that information spread is concentrated very close to the seeding node, in this case, Guardian itself. The New York Times versus Washington Post, you'll see that more or less similar, 100,000, 150,000 nodes, but New York Times actually has a large number of long cascade streams, whereas Washington Post has fewer long cascade streams. So what that means is, if you look at the user-to-user chains that get formed for New York Times, a lot of really long ones. But for WashPo, fewer long chains, although the diameter is about the same. That's the maximum length of the cascade chain. So again, very different form of propagation, which the visualization doesn't necessarily tell you. For financial news agencies, there's low edge-to-node ratio. What this is telling you is for at least these 3 financial news agencies, and in general, when we've looked at others in our sample, the number of individual tweets are very high. They don't have very long chains. Chains don't get formed. So there are individuals tweeting them, and they don't get retweeted and retweeted and retweeted. So very different formation of propagation. Yet, the articles remain on Twitter for a fairly long period, but not because lots of people are forming these cascade chains. So very different forms of propagation. And makes me suspect it's probably because, from what I understand, FT has a lot of its content behind the paywall. So I guess these are people who have actual subscriptions. And so individually they're tweeting them, but other people are not able to read the articles and retweet them. So that might be the reason for these shorter cascades or individual low edge to node ratios. And then finally, and then this is very interesting, is for some of these news agencies, the cascades are created by people other than the news agency, in particular for NPR and Wired and some of these WashPo, etc. It's not the news agency itself that's creating the long cascades, it's someone else altogether. In some cases, it's a journalist. In some cases, it's just an ordinary person who tweets articles, and they get retweeted and retweeted and retweeted, forming long cascade chains. So again, very different ways of propagation. So any questions on that? Some of you are journalists, so does this make sense? Yes?
Can you rephrase the difference between the nodes and the edge?
So a node is a user, and an edge is between two users when one user retweets another user. So when you have an high edge to node ratio, lots of edges compared to nodes, that means they're very tightly connected to each other. When it's very low, that means there are a lot more individual users not connected to each other. Question?
Were you able to draw any conclusions on verified nodes versus non-verified?
Yeah, so in most of these, so this conclusion that I'm showing you here is the percentage of non-media nodes creating cascades. A high percentage are non-verified nodes. So these are not a high percentage is not the verified journalists or writers who write for these newspapers, but other people, just ordinary people who are causing these long cascades.
Just to flip it around, so if you're a newsroom social media team, in terms of acquiring followers, are there any lessons saying that if you
Yeah, I'm gonna
followers of the
come to that in just a minute. If you hold on to your question, if I don't answer it, I will come back to remind me about it, okay? So then we looked at something called an ego network. So far I've been doing this analysis on the TAN. The TAN, if I can remind you, is the Twitter activity network, includes the news source itself, the news Twitter handle, and then all the other users. Here, the ego network, we're only looking at the network that's formed by the news source and the people retweeting the news source. The ego, because we call it an ego network because we center on one node, which is the news source, and then all the connections that are stemming from the news source. And that's a subset of the Twitter activity network. So here, so in this example, this is the BBC's ego network. So you see on top, and then on the bottom you see Guardian's ego network. So all of these are based on tweets that were initiated either by BBC on top or by Guardian News, and then users retweeting them and they getting retweeted. So with BBC, again, you can see that the three Twitter handles for BBC tend to reinforce each other, and over time they form a very dense connected network. For Guardian, there's the main news handle on Twitter is the one that initiates, and that is the one that gets retweeted, and once in a while you'll see those firework-like things. So level 1 means all the people who retweet the Twitter handle, the main Twitter handle for the news agency. Level 2 refers to people retweeting the level 1 retweeters. That is, if I'm Guardian, I tweet something and Eric retweets me, you're in level 1. And if Raju retweets Eric, you're in level 2. And so you can see how the level 2 network is adds more nodes. Level 3, you add more nodes. And then the maximum level is till whatever, till 10, 11, 12, whatever you go. That's making sense. So what's interesting is for BBC News, there are 3 handles which help spread the news. For all the others, it's typically 1. Okay, so the 3 that you see in level 1 are BBC Breaking, BBC News. So then we did another analysis of these, and we looked at follower participation. And this might get a little bit at the question you are asking, Raju. If not, I'll try to answer that. So here we have, in BBC's Ego network, BBC actually has the highest percentage of follower participation. So when you take this Ego network and you look at BBC News and you look at who's retweeting, so if you take out the other 2 nodes of BBC, you'll see as a percentage, look at the numbers of followers for each of the agencies, anywhere ranging from about, almost 2 million, 2.5 million for Mashable. There's almost 3 million for New York Times. So BBC News, it's about, at that time, remember this was between November 2012 and 13. These numbers may have changed today, but those are the numbers of followers. And on the 3rd column, you see the number of nodes actually participating. And out of that, 9.4% are followers. The rest of the nodes are non-followers. These are not people who are necessarily following these news agencies. Mashable has only 2.6% of their followers. Financial Times, very few followers actually participating in this propagation process. So you can kind of see, so if you are New York Times and you benchmark yourself against your competitors, let's say, BBC, Reuters, etc., you can see where you stand, how you're engaging your followers. And so it's not just the number of followers, it's how much you're engaging your followers. That's really important. So to me, the main takeaway is the fixation on followers. It's okay to have that fixation, but what you should really be fixating on is how to engage your followers and getting them involved in this propagation process. It's not the number alone that makes a difference. And actually what you want to do is to find out who are these other people who are not following you and yet actually helping propagate your articles, and how do you bring them into your fold, and what kind of incentives can you bring them so you can actually leverage their participation. So BBC has the highest. Okay, now here what we've done is, so again, remember what level 1, 2, 3 and maximum levels are. This is the Ego network. The Ego network starts with the news agency's Twitter handle. Level 1 is all the nodes that are immediately retweeting the news agency handle. Level 2 is people who are retweeting the level 1 tweeters. Level 3 are retweeting the level 2 users, and maximum is after level 3 it can go to 4 levels, 5, 6, 7. We didn't break it up any further. We just looked at the first 3 levels. What this graph shows you is if you look at the Ego network, remember the user-to-user network, you have all kinds of users, what percentage are in each level. So you look at BBC News, very different pattern, okay? Concentration, so level 1 retweeters, very few percentage-wise as compared to 2, 3, and 4. That's because what happens with BBC articles is they get retweeted by BBC News, BBC Breaking, or BBC World, and those get retweeted, so it kind of gets spread, and that's the different propagation process. Whereas for all the rest, you can see 80% of their propagation starts with people immediately retweeting the news agency node, and far fewer percentage of users at level 2 and maximum.
So what you are saying is that the BBC structure of retweets is mainly based on the fact that they have three big power engines.
All of them are equally effective on Twitter. Whereas for the other news agencies, it's their main one Twitter handle that's most effective.
So what is better?
So again, okay, that's a great question. I'm glad you asked that because this is just one metric we're looking at. I'm going to show you other metrics. And so there's actually a trade-off you make among the various metrics. So I can't say one is better than the other just based on a single metric. You want to look at multiple metrics and make that decision. Question?
I just wanted to check with the BBC News pattern.
Yeah.
If you're saying the level 2 is all is at BBC News and at BBC Breaking, for example, it'll be the other BBC accounts.
So level 1 is mostly the other, so there's a, no, level 1 is the ones who are retweeting BBC News and typically it's the other two.
Okay, so
level
that's
2, 3, and 4 and maximum are all the others. So level 1 is all the users who are immediately connected, directly connected to BBC News.
okay. So is one level down from the BBC World would be the red, whereas
So
with the
World,
others it would be the
BBC
blue.
World and BBC Breaking would be in level
Yeah.
1.
Yeah.
And then all the others are...
So the others would probably be more likely non-branded accounts.
Correct.
Whereas with Reuters, for example, in level 1, probably non-branded accounts in level 1, most likely. Is that right?
can you say, I'm sorry, I didn't understand
Okay.
your question.
So, in level 1 on BBC News,
Yeah.
we know it's branded accounts, usually the big branded
The
BBC accounts.
two of
Yes.
them mainly, but there's
Yes.
others also, but a much smaller percentage
Okay.
as compared to these other news agencies. Look at
Yeah.
the width of the band, the length of the band for level 1 for all these other agencies versus BBC.
So if we took Reuters and we looked at level 1,
Yeah.
the chances are there wouldn't be Reuters branded accounts so much in that level.
As compared to the rest
As
of the
compared to
nodes,
BBC News.
because this
Okay.
is the percentage of all the nodes in that network, how many of them are at level. So if I take the entire Ego network, there are 100,000 nodes in them. For Reuters, Guardian, etc., about 70% of those are level 1. Whereas for BBC, a very small percentage is level 1. They're all spread in level 2, 3, 4. Does that make sense? Any other questions? Okay, so really BBC has a very interesting pattern of propagation. And then you can see for these others, level 2, level 3, there's variations in 2 and 3, anywhere from about 20 to 30% in level 3 upwards. Okay, so I'm going to come back to your question, Eric, about which is better, okay? Because that's a question I want to answer in the end. So I'm going to go through this fast. So this is all about networks, right? But we also want to understand, so we saw some networks. We saw networks for these agencies, and we saw different propagation patterns. We see different depths of propagation. But what about rate of spread and lifespan? How long do these articles really last? Is it always the case that when there are long propagation chains, the articles will last longer on Twitter? This is lifespan on Twitter we're talking about, right? So from the time the article gets published on the website, from the time it starts on Twitter, the first tweet comes out, how long does it last? And so we looked at the time difference between the last and the first tweet. Now the last here, remember, is in our data set. And so we took the whole year to look at last, because sometimes what happens is an article starts to die down on Twitter and then suddenly it gets new life and it comes back. Happens for various reasons. Some controversy happens. So it's about a basketball player and there's an article and then he breaks an ankle or something and then that news article comes back. Or, someone dies and then, they kind of bring that article back. So there's many different reasons why articles get new life. So we kind of looked at the first tweet, that was posted on Twitter containing a URL to an article and the last tweet, and looked at article survival. So I want to show you a little bit about this lifespan by running this video. Excuse me, at the back, do you see a play button on my video? Because I'm not able to. If you hover your mouse around this, you'll see a play button. I want to show you. So I'm going to show you how this network forms and grows over time. And this is for I need to be able to play this video, and I'm not able to. Is there a way to, or if you can pass control back to my laptop? See, there's a play button here. I don't see the.
No, I don't know the reason. That don't work.
Why isn't it working?
This
Is that the mouse? Oh,
It
maybe
isn't
if I
plugged.
plug in the mouse.
Yeah.
Okay. Technical
It's not
challenges.
plugged.
Yeah, let's plug it in.
don't work.
Let's see. Okay, while it's installing, if you have questions, please ask.
Okay.
Oh, this is working now. Okay, actually, let's go to, let's go down to. Okay, so I'm going to show you, thank you very much. So this is actually going to show you from the time the first tweet comes out, how it spreads. So this is kind of a dynamic visualization. And so the number on the right side is the hour. So the first hour, the fifth hour, the sixth hour, this is how the propagation network forms over time. See that on the orange circle over here is this, what I call the seeding node. This is for New York Times. It's over a 24-hour time period, a little bit more than 24 hours. So you can see that this is all of the level 1 propagation that happens. And then there's this huge community that's, separate from the seeding node. And then there are these interesting little communities that are forming. And so if you go in and start to add context to these little communities that are forming over a 24-hour period. So this is all the articles in one 24-hour period. Yes?
Okay, when you are the New York Times, you have no clue about what's going on in level 2, right?
When I start this,
No. When, let's imagine you are the New York Times,
yes.
okay? So you know what's going on level 1.
Yes.
Because you see the retweets.
Yes, immediate
Or you
retweet.
see your name, or you see the handle.
Yes.
But in level 2, you don't see it.
You may or may not see, it will have the New York Times article embedded in it.
Okay, but
And even in level 1, you may or may not see it unless you look for the article URL, because when people retweet you, they may modify the tweet, and they may not always refer to you by @New York Times. So in any of the levels, you may or may not see it. Whereas this actually tells you how that propagation.
So I guess Twitter has to do a better job on the number on the Twitter number of retweets.
He's looking at you, Jordan. Right. That's actually a good suggestion. I don't know what Twitter shares back with news agencies. But certainly, in any retweet situation, they may have a hashtag where they refer to New York Times. They may actually refer to the Twitter handle, or in some cases, they may just have the URL of the article.
There's lots of analytic tools out there that will monitor the use of a URL across Twitter. So you can get an account and then
saying is that on the New York Times website, we will see maybe 200 retweets.
On the website?
On the website of the New York Times.
Okay, that's different from this though, because people could be retweeting by going to the New York Times website, or they could have read the article and then they shorten the URL using some URL shortener and then independently tweet it or retweet it, not necessarily from the website. So on the website, the count you see is only the people who clicked on the tweet button from the website. Yeah, and whereas this includes everything. But what is really interesting is I want to dwell on this. So you saw how it kind of spreads and forms different communities. And so there are some isolated communities that are, this is someone who actually tweeted a bunch of articles and got retweeted by this community. And this is just within that first 24 hours that you see. So, and we went in and did an analysis of all these different communities. And some of these are actually journalists who write for New York Times. Others are just ordinary people. Some of them are verified accounts, some of them are non-verified accounts. And there is no pattern really to when a verified account will be participating and when it'll be non-verified account. But by kind of observing these networks, you can go in and in almost real time, you can look at the profiles of these people. And these are what I would call like the influencers during that particular period of time. So that's kind of touching a little bit on your question. But it doesn't quite answer what percentage of verified versus non-verified accounts. Yeah.
Another question.
Yeah.
When you are the New York Times or the New York Times editor or the New York Times journalist
Yes.
who wrote the piece,
Yes.
you want to know that.
Yes.
But you don't today.
Yeah, okay, but here we can. So this visualization analysis we've done, we've set up the pipeline in almost real time, and then when you hover over it, you can see the profile of the person who's causing the cascades.
Okay, but when you are the news media, how can you improve the knowledge of the power of your article?
Right, so you want to say...
I want to know that if I am the author, if I am the journalist, I want to know that, but today I am not able to know that.
Right, and this will be able to tell you that. Yes, exactly. Yeah. So this is for a 24-hour time. Yes. Previous one? Okay.
Are the community isolated, context related? I mean, culture, or sports, or...
Very good. So you're looking at the topic, right? Yeah, so this particular one includes all the articles in that 24-hour time period, but I can actually slice it based on the topic. So New York Times has a classification, and it gives a classification of articles. I can use that. So this one I haven't shown you, but you can actually do that. You can see how sports articles spread in a 24-hour time period, how politics are. Is that what you're asking? Yes, so you can actually do that. And what's interesting is that you can actually see different patterns of spread. You'll see one community for sports. You'll see a very different community for current events and global events. And then for the blogs, there's a totally different, different community. I don't have the visualizations here, but I can show you that, offline if you like. Okay? So that's a great question. Okay, so this one was, this is for a single article. So what I showed you previously for all the articles for New York Times, then when we were going through this data set, we observed that in our data set, there were some articles that spread very rapidly within the first few hours, like within the first 24 hours. So we kind of zoomed in, and this is one single article that was originated by Mashable. It goes by really fast, so I'll play it a few times if you like. And so here's how it starts. See, that first level builds up very fast for Mashable, for this article. And then you have the level 2. And there are also the independent tweets that you see here. and then you can start to see in the second hour more of level 1 tweets. So this is very typical of Mashable, is because Mashable has a huge level of following, but it's not all followers, very small percentage of followers, and yet the level 1 retweets happen very, very fast for Mashable. And then it kind of goes. So we were very interested in knowing what this article was, because this had the highest rate of spread of all the articles in our entire data set with 200 million tweets. Turns out this was an article that was on Google+. This was during that time period, and it compared Google+, its pros and cons, and why Google+ would kill Facebook, which didn't happen. But people read it, and we assume they read it, and they started spreading it around, and this had like the highest rate of spread. So very interesting. Okay, so now I'm going to go to this lifespan. So the idea of this lifespan and rate of spread came because we were looking at these networks, and we said, so the static snapshot tells us about how far it's spreading, etc., but tells us nothing about how long they last or how fast they spread. And so you can actually, so we looked at the lifespan, which is the difference between first time difference from the first tweet to the last tweet. And the longest lifespans were for, so this is number of articles that are surviving over the first 0, 1, 2, 3, up to 50 hours, 100 hours, 150, and so on. So the highest survival is for articles from New York Times, that is, and Mashable and BBC. From the time the first tweet comes to the time that the last tweet comes within our static snapshot. So it could be that, after the 200 hours, if we had taken, even longer time period, we might have seen a rebirth of the article in the next year or something like that. The shortest time spans were for Bloomberg, Forbes, and surprisingly Wired. That was very surprising for us. I'm not quite able to understand why Wired has such a short lifespan. But this is kind of average. And then we have survival distributions. What percentage of articles survive the first 2 hours, the 3 hours, 5 hours, and so on. And so for Reuters, for up to 17 hours, you have about almost 75% of articles. For Guardian, very high survival rate in up to 17 hours. And then they kind of die out. And Forbes, Mashable, and Wired, their articles have a longer lifespan. They survive up to 35 hours. And then so many of their articles survive up to 71 hours. So you can actually see survival of articles, that is how long they stay circulating in Twitter, and you can kind of tell from that based on, so the rate of spread is not related to the survival rate at all. Just because it spreads fast doesn't mean it survives for a long time, or how many articles will survive for so many hours. You can't tell any of that. So this is another way of looking at it. More than 18 hours, Financial Times, Ars Technica. And so we have all these other kinds of survivals. So I'm going to kind of skip over some of this because we're running out of time. We have 2 minutes. So then we did a rate of spread. And did someone have a question? No? Okay. So I'm going to quickly skip over. We did a half-life rate of spread study. I'm also going to quickly skip over because I want to give you the main dashboard and what it looks like. Okay. So you can also look at, how the rate of spread. So these are some of our findings. BBC maximum reach in terms of affected users, retweet levels, distribution on Twitter, best article survival chances, so on. It's majorly supported by 2 other BBC accounts. Reuters, if you're comparing among the 12 agencies, medium article lifespan compared to other agencies, best edge to node ratio indicating high percentage of user interaction. For New York Times and Mashable, very similar tweet volume and rate of spread, but Mashable has a high percentage of level 1 tweets. New York Times has long cascades, so big difference. And then Guardian, most of the tweets are in the first level. highest median number of tweets posted in the first hour, third highest rate of speed, of course, based on hour. So I'm going to skip over some of these and go to my dashboard here. So what I've shown you really is a lot of different metrics. Some network-based, some non-network. So you see here, this is kind of the dashboard you can build if you're Twitter or if you're a news agency. You can actually collect all this data, and you can look at diffusion depth. You can look at how many, what's the magnitude of nodes in your level 1, what kind of follower engagement do you have overall in your entire network, and then kind of the follower density, which is out of all the nodes in level 1, how many are followers versus non-followers, and then out of all the nodes in your network, how many are followers in level 1, level 2, etc. So here are some findings. So these are all numbers. What do these mean? Well, news agencies with high tweeting activity have high propagation depth. And that's okay, that sounds okay. But there's really no an inverse relationship between propagation magnitude, that is, the number of nodes involved in level 1 versus propagation depth. Inverse relationship. Follower engagement is directly proportional to propagation magnitude. So more it propagates, the more the followers are engaged. Or more followers engaged means higher propagation depth. Really, it's the directionality. And so the main message I want to give you from some of this is that involvement of followers is more important than number of followers. So I really think we need to look at how we're involving the followers, what kinds of articles. And like I said, each genre or topic has different kind of involvement. So looking at who are the followers being engaged for different topics and how to bring in more people is really more important. And like I said, it's not always followers who are helping propagate, it's non-followers. So looking at the non-followers who are constantly engaged and bringing them in as followers, maybe giving them some additional incentives, maybe gamifying it. You know, gamification is a big thing these days when you give rewards to people. So bring in engagement using some strategies. So this is kind of the implications. So you can see we have a lot of different metrics. I didn't go through all of them, but really the implications are it's a different perspective on understanding how social media gets used for news article propagation. Very different perspective. It's a different model, and specifically in understanding the role of Twitter. You can measure how influential you are on Twitter, how influential your articles are. Detailed insight into the performance of news agencies. You can benchmark yourself against other news agencies because this data is available. It's not a secret. It can be used for pricing. So micro pricing, for example, right? Right now, our model is you give a digital subscription, right? Well, for some of these articles, maybe you want to bring in these non-followers and offer them an incentive, like iTunes does, give them an iTunes for newspaper articles, build models based on what you see happening in real time. And this is what we want to do, is to understand how all of this is really impacting subscriptions. Can you convert the people who are your influencers and who are not subscribers into subscribers? So for this, we'll need to partner with news agencies to get their subscription data and to link up their Twitter accounts with their subscriptions. Understanding the role of followers. So for future research, what we're doing, 5 minutes. Okay, I'm going to finish up now. So these are some of the things. In particular, I'd really like to partner with news agencies to understand impact on subscription readership to help set strategy. We're also, what we found from our analysis is news agencies tend to have what I call a backbone network. And we've designed some algorithms to extract the backbone network. This is the stable set of users who exist time after time, regardless of what time period you're looking at, regardless of what type of articles you're looking at, this is the backbone. And often this backbone is not just unique for a single news agency, it's a backbone that spans multiple news agencies. And so our next paper that we will be writing is on this backbone network analysis of some of these other things. So I'm going to stop here. This is our Insight website. That's our Twitter handle. You can Google us. We're on Facebook. You can look at the types of articles we're working on. Oh, it's insightua.org, www.insightua.org. Here. So, if there are any questions, I understand we have about 5 minutes. Yes. So Eric, I don't know if I answered your question about which is better, right? So you want high rate of spread, you want long lifespan, right? You want long propagation depth.
Size doesn't matter.
Size, yeah, it's not number of followers.
Something you didn't mention is frequency. For one tweet, does it matter to tweet several times the same tweet?
Okay. So what's interesting is our data set in... So same article you're talking about, whether you should continue...
let's say every 8 hours to do...
The same article.
Yeah, same 3 times in 24 hours. Does it make sense?
I don't know the answer to that question. I'd have to go back, look at the data set. But I know that most of the tweets that we saw, each article gets tweeted by a news agency only once in our data set. I think we had very few articles that were tweeted more than once. With the only time when it happened was with BBC, where one BBC account would tweet an article and another BBC account would retweet it, and then it was effective. But when that happened with the other news agencies, it was not as effective. With Mashable has a handle and Pete Cashmore has a handle, and they both tweet the same article. And the audience kind of gets split between them. So I don't know if this reinforcing really helps or not. I don't have an exact answer to that. But really what we're seeing is there's no one single metric that you can use to say you're performing well. You really have to look at a host of these metrics. And you may not always be able to optimize on every single metric, so you decide what is it that you want to be best at. But I think ultimately it's not so much about how fast it spreads or how long it stays. It's about how much money the news agency is able to make through subscription. It boils down to that bottom line. But these metrics can be connected to that. Any other questions? Okay, thank you very much.